What is the ETL process? ETL stands for extract, transform, and load, which is a critical process in data warehousing. The ETL process involves collecting data from various sources, transforming it into a format suitable for analysis, and then loading it into a data warehouse for querying and reporting. It is the backbone of most data warehousing projects and plays a crucial role in ensuring that data is clean, consistent, and organized for business intelligence and analytics. Data often comes from different systems, such as databases, spreadsheets, CRMs, and even third-party applications. These systems may use different formats and structures to store data, and the ETL process ensures that all this information can be collected, standardized, and moved into a central repository for meaningful analysis. Without ETL, the data would remain in silos, making it difficult to conduct effective business analysis. Why ETL is important? Data integration. Data often resides in multiple sources such as relational databases, cloud platforms, flat files, and web services. ETL ensures this disparate data is consolidated into a single data warehouse. Data cleaning and standardization. Data from different sources can be messy, inconsistent, and non-standardized. ETL helps to clean the data by removing errors and inconsistencies, making it suitable for analysis. Performance optimization. Data in its raw format may not be suitable for querying. ETL helps transform and optimize the data to ensure faster query performance in the data warehouse. Ensuring data quality. ETL processes include data validation and enrichment techniques to improve the quality of data before it is loaded into the warehouse. Now, let's dive into each of the major steps in the ETL process. Major steps in the ETL process. The ETL process consists of three major steps: extraction, transformation, and loading. 1. Extraction. The first step of the ETL process is extracting data from various source systems. Data can be extracted from databases, ERP systems, flat files, CRM platforms, web services, or any other system where data is stored. The goal of this step is to collect the relevant data that is required for analysis. Data sources. Relational databases, e.g., Oracle, MySQL, PostgreSQL. Flat files, e.g., CSV, JSON, XML. APIs and web services. Legacy systems. Cloud storage platforms. Types of data extraction. Full extraction. In this method, all the data from the source system is extracted. This is commonly used when a data warehouse is being built from scratch, or during periodic data refreshes. Incremental extraction. In this approach, only the newly added or updated data since the last extraction is pulled from the source systems. This method is more efficient for ongoing data warehouse updates. Challenges in extraction. Source system complexity. Different source systems may have different formats, making data extraction difficult. Large volumes of data. Extracting large datasets can strain system resources. Real-time data needs. In some cases, businesses require near real-time data extraction, which can be challenging to achieve efficiently. Transformation. Once the data is extracted, it needs to be transformed into a format that can be loaded into the data warehouse. This is often the most time-consuming and critical part of the ETL process. Transformation includes several substeps, such as cleaning, filtering, aggregating, and converting the data to the desired format. Key transformation activities. Data cleaning. This involves detecting and correcting errors or inconsistencies in the data. This could include handling missing values, correcting errors in data types, or removing duplicates. Data filtering. Not all extracted data may be useful. Filtering helps remove irrelevant or redundant data from the dataset. Data mapping. In this step, the fields from the source systems are mapped to the destination schema in the data warehouse. For example, customer name in one system might be mapped to client name in another. Data aggregation. In some cases, data needs to be aggregated for reporting purposes. For example, daily sales data may be aggregated into monthly or yearly totals. Data enrichment. Additional data might be added to enhance the dataset. For instance, geocoding may be applied to addresses to add latitude and longitude data. Data type conversion. Data from different sources may use different formats. For example, dates might be stored in various formats like dd/mm/yyyy or mm/dd/yyyy. The ETL process converts these to a standard format. Derivation of new values. Transformation can also involve creating new derived values. For example, combining first name and last name into a single full name field. Transformation rules. These are predefined rules that ensure data is transformed correctly. For instance, if a field should only contain numeric values, the transformation rules will ensure that only numbers are loaded into that field. Challenges in transformation. Complex business rules. Applying complex business rules for data transformation can be challenging, especially in large datasets. Data quality issues. Poor quality data from the source systems can cause transformation failures or require extensive cleaning efforts. Data dependencies. Some transformation processes depend on the availability of other data, adding complexity to the process. Loading. The final step in the ETL process is loading the transformed data into the target data warehouse. The goal is to load the data in a way that it can be quickly accessed for reporting and analysis. Types of loading. Initial load. This involves populating the data warehouse for the first time, with all the historical data. Incremental load. Once the initial load is complete, subsequent loads involve updating the warehouse with new or updated data. This could be done periodically, e.g., daily, weekly, or in real time, depending on the system requirements. Full refresh. In some cases, a full refresh of data might be needed where old data is entirely replaced with new data. Loading methods. Batch loading. Data is loaded in batches at scheduled intervals, which is ideal for large datasets and periodic updates. Real-time loading. Some systems require real-time data loading, where data is continuously loaded into the data warehouse as it is updated in the source systems. Challenges in loading. Performance. Loading large amounts of data can impact the performance of the data warehouse. Optimizing the load process is essential to avoid downtime or slow query response times. Data integrity. Ensuring that the data loaded into the warehouse is accurate and complete is crucial. This requires checks and validations to detect any errors during the loading process. Data duplication. During incremental loads, care must be taken to ensure that duplicate records are not introduced into the data warehouse. Conclusion. The ETL process is essential for building and maintaining an effective data warehouse. The process of extracting, transforming, and loading data ensures that all relevant information is collected, cleaned, and stored in a format that allows for fast querying and meaningful analysis. While ETL can be complex, it is a critical function for any organization looking to leverage data for business intelligence and decision-making.